Hi there. Data about employment for males and females in a small rural area are shown in the table. Male, unemployed, 206, employed, 412. Female, unemployed, 358, and employed, 305. A person from this area is chosen at random. Let M be the event that the person is male, and E be the event that the person is employed. So M for male, and then E for the event that the person is employed. Find probability of M, that is male. Find probability of M and E, male and employed. Third question, are M and E independent events? Justify your answer. Given that the person chosen is unemployed, find the probability that the person is female. Now for the first part, to find that the person is a male, so we need to find how many males employees we've got. 206 plus 412 is actually 618. So we've got 618, and all of that divided by the total number of people over here, and the total number of people turns out to be 1281. So if we were to do this, you should be able to get 0.482. So here we are. The second part, we need to find that the person is a male and is employed. Male and then employed, so we've got 412 of them, so that's 412 over a total of 1281, should be able to get 0.322 to three significant figures. Now for the third part, we need to are M and E independent events? Okay, so what do we mean by this now? And we need to justify our answer before we answer. If we say it's independent or not independent, we still need to justify the answer. So how do we go about and do this and prove that it's independent events? So that means we're going to have probability of M alone of male, which is 0.482. We found that in the first part. And for then the probability of employed people, so probability of employed people, we have all of these employed people here. So that's 412 plus 305, which comes to 717 over 1281. So let's do this in our calculator, and we get something like 0.5597. 0.5597. Now if we take this multiplied by that, so probability of M times probability of E, okay, we're going to get I'm just doing it right now in the calculator, 0.26978. So probability of M times the probability of E is going to be equal to 0.482 multiplied by 0.5597, and this should come to 0.26978, and so on. Now from here, what do we also need to take into consideration? We look at probability of M and E. So that basically means probability of M intersection E. So probability of M intersection E, all right, so male and then employed. So how many males and employed? M and E, all right, we did that somewhere and we got 0.322. So clearly it can be seen that 0.322 is not equal to 0.269. So these two are not equal. So when that happens, what are we saying? We're saying that the probability of M intersection E is not equal to probability of M times probability of E. So that said, it means that therefore M and E, okay, are not independent events. Right, so now what about the fourth part of the question? Given that the person chosen is unemployed, find the probability that the person is female. So we need to find the probability that the person is female given that the person is unemployed. So what we have then is female and unemployed, F, and then unemployed, okay, divided by person being unemployed. Now female and unemployed, okay, so we have, when we look at the question here, female unemployed 358, okay, so that's 358, okay, over a total of 1281, and all of that being divided by the person being unemployed. So how many unemployed person we've got? We've got 206 of them plus 358 from the table, so 564 here. Unemployed 206 plus 358, so that's the total number of people who are unemployed. Now that is then 564 divided by 1281, and of course you cross this out and you're left with 358 over 564, which comes to 0. For my calculator, 6347 and so on, so approximately to three significant figures, 0.635. Here we are. Take care.